The Newton's law of cooling states that the rate of change of the object's temperature is proportional to the difference between its own temperature and the ambient temperature it's in. This verbal statement can be translated into a differential equation, which is as follows. The rate of change of the temperature with respect to time equals K times the difference between T and Tm. In this equation, K stands for the constant of proportionality. T is the temperature of the cake when time is greater than 0, and Tm is the ambient temperature. Some real-life applications are to predict how long does it take for a hot cup of coffee to cool down to a certain temperature, and in crime scenes, it can determine the time of death of a body depending on its temperature at the moment of death and its current temperature.
After making the research about Newton's law of cooling, we measured the room temperature. Then we made the cake and waited for it to be ready. Right after we took it out of the oven, we introduced a thermometer in the cake to get the temperature. Then we waited 5 minutes and measured the temperature again, repeating this step every 5 minutes until 15 minutes had passed since we took it out of the oven. After gathering all the temperatures we needed, we started to design the equation.
The initial thing we have to do is to design the equation. First, we look for Newton's law of cooling. Then we pass the parentheses to the left side of the equation, and also pass the t to the right side. Then we use the logarithmic rule to integrate the left side, and after we integrate both sides. Then we replace u with t minus ta, and add an exponential to both sides to cancel the natural logarithm. Finally, we separate the exponential. With the equation we got, we replace the capital T with the temperature of the cake when it just left the oven. Replace lowercase t with the time and replace Ta with the room temperature. Since exponential to the 0 is equal 1, we pass 25 Celsius to the left side and subtract from 90 Celsius. The result would be C equals 65 Celsius. Then repeat the same process but with the value of the temperature after 10 minutes. After that, we replace the value of C that we obtained in the first equation to the second equation and solve for exponential. Then we add natural logarithm in both sides to cancel the exponential. And finally, we divide natural logarithm 52 Celsius between 65 Celsius over 10 and we get K. Now that we've got both K and C, we can replace their values and obtain our final equation. To compare our results with the equation, we replace lowercase t with 5 minutes and solve for capital T. We then compare results with previously obtained ones and repeat the last two steps with the data from 15 minutes.